And good evening everyone who is watching the stream of VD. Arrives on air with a rare scene here with a DIY stream. So that's has always been a scene on my channel. Some a little bit of DIY, but since it's only a little bit, many people don't even know. So what are we going to do tonight? So remember this board? So I got it from AliExpress, and this is a digital audio converter. You send in your SPDIF signal or optical or electrical, so and you get just standard line output. So that's it, nothing special. What makes this board good, I mean, when I got it, I didn't know it was going to be good because I had a very expensive device that cost almost 100 bucks that didn't work actually good, considered hi-fi, and it wasn't hi-fi because of the power supply, and the overall sound was kinda so not good. I was looking for something better, but it was even more expensive, more than 100 bucks. So, and then it was all from AliExpress, and then I found this board that was like, I don't know, 15 bucks maybe, DIY, yeah. So, and I've already tested it, I've already been using it just without a case. I've prepared everything to mount it in a case. What makes this board good, it's that it takes proper power, and proper power for audio. It would be like not just 9 volts or like 5 volts or anything. It's when you have plus voltage and minus voltage. So, and when you have plus and minus voltage and the middle point between them, so that's what makes actually the operational amplifiers work properly, without additional shifting, without using additional what's it called, converters, voltage converters, power converters. So and this one kinda uses plus 15 minus plus 12 minus 12, which is actually pretty good. Lil Sonic, good evening, welcome. I'm putting this DAC board, DAC digital audio converter, into a case with a power supply. So I need this digital audio converter to connect my TV that's being fed all sorts of signals, but mostly like I have a separate pretty much PC connected to my TV. So to take the sound from my TV using optical connection and send it into my vintage amplifier, Japanese vintage amplifier that only takes simple line input stereo, nothing special. So we've tested this board around 2 years ago, and since then I've been using it on and off, but without a case. So now it's time to put it all together nicely. So I've been kind of working on it sort of in the background, so preparing the case, and it's not a good case. Usually these days people would just print one, but I don't have access to 3D printers, and I'm not a designer. So, and I try to actually do it as cheap as possible. Gonna get you, good evening, welcome. Switching 200 with hot water heater, thermostat designed for AC. DC relays to turn on elements. Sorry. Switching with a hot water heater, thermostat designed for AC. Tiny engine out of Lego. Yeah, I wish I had that, but no Lego around. So So you need to switch direct current with just something designed for alternating. Technically, how long the relays would last would only depend on the current. So that you're switching like 240 volts, that doesn't really matter. If the current's small, there's no difference between, there's actually, for relays, there's no big difference between AC and DC. So the sparking might be a problem. But again, if the current's small, then there will be no sparking. DC relays to turn on the elements. So I have prepared a case. It's very big, but enclosure. It's very big. See, gigantic. So I made all the holes. Unfortunately, it turned out that I don't have files of the right size, either too big or too small to fit in these holes. So the holes stay like that, unfortunately. But they're all gonna be covered. So the holes that could be drilled, I've drilled. So it's all pre-drilled already. It's all already checked that it can be mounted properly. So our goal here is only to assembly. Hot water heat designed for 2040 AC. You run to one it on. Where did you find 240 DC? Where did you find 240 DC? I mean, it's so rare to high DC voltages of that voltage. That's very high. The seekers to let go. I'm not sure. Lil Sonic, thank you for the follow. Actually, there was no notification sound. Solar panel output. Ah, yeah. Listen, man, I got to look into it. I don't really remember. Nah, Lil Sonic, you have a good one. Thanks for jumping in and thanks for the follow. So I don't really remember, but depends on design of the water heater. So, but it's gonna actually consume a lot since it's a heater. So at least like a kilowatt, maybe a couple, maybe even 3. So yeah. Okay, so the holes don't look great. My apologies. Don't have the right files to just file it all. So I just pretty much melted them through. The ones that are round shaped, these I drilled. So the thing about the size of it is that since this board needs plus 12 minus 12 and the middle between them, so I have to use a proper transformer for actually, and plus and minus 12 AC, speaking of actually unexpected currents. So this takes AC. It kinda rectifies it on its own, has its own rectifier, and we tested this thing. Actually, it's so good. I tried to create interference by just moving the transformer around it, pretty close working transformer, and I couldn't. So, and the quality was way better than on that device, DAC DAC for like $100. So I even I pre-drilled all the holes, everything's here, and I even actually made some wires. So we only need to just get it all together. So the thing about one thing about this case and the way this thing is going to work is that, see, I mounted this transformer on plywood plate. That's because technically this box is not metal, so it doesn't have any ground. The transformer itself, the case, doesn't have any ground, So I decided not to ground it and to run it just like old device or like low power device without any ground. That's why I've insulated transformer completely from the outside of the case. So the mounting screws, they're not going to be touching the transformer itself. If something goes wrong with the transformer, then it stays inside. That's why I'm going actually to use fuses, and because I like to overcomplicate things, just to make it easier to use this device, I actually made two different power inputs just to be able to place it more conveniently. So when it's convenient to have all the inputs on one side, then yeah, it's power coming in, all the inputs and outputs coming in, but then power can be fed from this side too. I just like overcomplicating things. So let's start soldering. So these have been all checked. And the only thing we have to do is just start soldering. One of the main things here in this circuit going to be the switch, power switch, that's gonna be switching not just power but between two different power inputs. And since it has these type of connectors, I actually pre-crimped some wires for it, so that's pretty much would be pretty easy to connect. So inside the case, one thing that I want to do though, I want actually to, before soldering anything, I want to make these a little bit oh crap, I mixed them, unfortunately. A little bit safer. So yeah, the case is going to be of course closed, but still if I just connect all of them like that, they're going to be exposed inside the case. But we can fix this a little bit by just using some thermal shrinking tubes, so like this, and pretty much minimizing the amount of the exposed metal like this. The color doesn't matter because it's all AC, so there's no plus minus there, and there's not going to be phase dependence. It's not a phase dependent device, and the connectors, the power connectors, are not phase dependent. So like this, a little bit safer inside, though I just kinda do this stuff because I can, because why not. This one turned out a little bit better. So these are the wires I already crimped, the connectors onto them. Was working on that stuff in the background quietly. That'll do. So there's 3 more. This is not needed, and generally you won't find it inside enclosed electrical appliances, but why not? Why not if I can do it? So, and there's the one that's going to feed the transformer. I'm burning them a little bit, but nobody said it's going to be pretty. I cannot do pretty. That's kinda my thing. I can do things, but not the pretty way. Here we go. So let's where did it go? Here it is. So I have already insulated everything we don't need here. Magic Song hasn't come out. Yeah. So these are old Russian transformers of TPP series, Soviet, produced by Soviet industry in just enormous quantities. Different numbers on them mean different types. There's like a whole range of them. They are quite universal. So this one actually is produced in the year when I was born, 80. So that's kind of like almost the same age as me. So, and you can buy them on Russian like Russian versions of Craigslist and Facebook Marketplace, so Russian eBay. So pretty much there is a lot of them around floating, and you always can find the one you need. Combine the primary windings, the secondary windings, based on the documentation. They are very well documented, standardized. So that's the good part of the good thing about them. They are very standard, all of them. So, and pretty much any voltage you can get out of them. And there are small ones, there are big ones. This one, I think it's like, I don't remember actually, but I know how powerful is this one. It's powerful, yeah, but this board not going to consume more than, I don't know, like half a watt maybe. So, and again, since we are working with AC, there's no such thing as polarity. There's phase, but in this case it's irrelevant. So what I wanted to do, I wanted to solder it first and actually do it properly, like this. I don't know if you can see, it's a little bit dark, but because I'm using sorta kinda that type of exposure, should probably change the exposure. Okay, let me find the right thermal tube. I have a bunch of them. This one's too big. Strange. I had the right one that I was using. The smaller one. Well, I mean, technically that'll do. We don't need much. Just a little bit to cover it. So since I already designed the position of all the things inside the case, even prepared all internal wires to the length and crimped them to make mounting easier. Just we're pretty much mounting everything together, nothing special. So and yeah, I understand this is the mains connection, and when you work with the mains, you're supposed to actually use as less soldering as possible. But what you're gonna do, these connections here, they are this type of connections, they are not for crimping. So, and this is already all connected in the right way to give me what I need. I send 2030, 2040 volts on this side, and on that side I get what I need. Plus 20, plus 12, minus 12. Here we go. Nice and clean. Now this here. Got to be cut to the length, I suppose, or maybe left like that, and then the cable would go around. That's the idea. There will be no stress on it, it's just I'm positioning it for now. Yeah, I'm not going even to cut it. It's already kind of pre-soldered, so I will just solder it here. Pretty big wires because it's the mains 220, 200. Actually, it's quietly became 240. I keep monitoring my mains voltage, and it's when it's daytime, it's usually 236, 237. When it's nighttime, it is usually 240, 241. That'll do. So let's see if we actually have the length, because I'm not sure. So it's supposed to be like this, and this supposed to be like here in this hole. That's where the switch going to be. Here we go. So that part, the dangerous part of the transformer, is to the wall. The less dangerous part is to the opening of the case. So this is the primary, the mains, this is the secondary. Okay, now let's start assembling things in here. That's gonna be fun. That's gonna be fun. So first of all, we have two power inputs that we can switch between. So it's going to be then two fuses. I could have used one, but now it's going to be two. So, and I'm kind of using, I'm going to solder, pretending that I'm going to send the phase from through them, but since the connector I'm using, it's this one for the power, and you can pretty much insert this both ways. Oh, it doesn't even go in, so you can insert it this way, or the other way around. So the device is kinda going to be not always properly color coding the phase and the null wires inside it. So just to make it easier, these I'm going to solder inside the case, and these outside. So let's work on that. So I'm using the very old school type of, is it a little bit dark? Oops, okay, let's make it less dark. Just give me a sec. Okay, that's kinda a little bit too much. That cannot fix it. should go only should go one way. What do you mean? No, it shouldn't go one way. The way it's designed, there's no difference, unfortunately. The way it's designed, there's no difference. It's phase irrelevant. I know, what's that? Some UK plugs and some of the American plugs, they are phase not independent. But here we have plugs that pretty much can be inserted either way. Some European plugs that are kind of compatible with our plugs, they are not phase independent, but ours they are. So when you have this on the other end, so this can go in the wall socket. The wall plug can go any way as well. So okay. Got to start soldering. We don't have all night. I'm already pretty late. So just adding a little bit of solder to it. So let's hope this solders, because I actually never really tried it. Oh yeah, nice. It barely takes any solder. Always a problem. Okay, I have some acid here. Just give me a second. This needs to be first pre-treated with a little bit of acid. Just give me a second. Oh boy, this acid doesn't look good, but it should do. I have a small cap here and I'm going to need some Q-tips. Just give me a second. So it needs, of course, a little bit of heat. Okay, that's just orthophosphoric, I guess. Oh, it's kind of probably degrading. I never really well, I mean, there's a whole bottle of it and I use like 2 drops maybe a year. Let's hope it's still acid. And let's pre-treat these ones at the same time. It has become really gooey. It's like a little bit slimy. Hope there's still at least a little bit of acid, because I don't want to use a tablet of aspirin for that. It makes way more unpleasant smell, gas actually. But that's just a sort of kinda a quick tip. If you don't have acid, you could use some aspirin tablets. Oh yeah, way better. Immediately gets covered. Okay, the lamp is not really properly shining here. So is focus good? Let me take a look. Focus is good. The second camera is not really showing anything. Okay. Works like a charm. Just was oxidized, probably a little bit, and then we remove the oxidization with the acid. So good to know that acid still works. That gooey degrading. Oh yeah, good. You unfortunately cannot see it, but takes it immediately now. Okay. This it's boiling over there. Boiling off. Okay, the problem is that some of them are going to be connected with these connectors, crimped connectors, but some of them are going to be soldered anyway, so it's kind of a mix of connections, which will make assembling it a little bit harder. So let's start. Oops, I'm going to lose sound for my headphones are, well, earplugs, low on power. So now I'll have to, well, I've already kind of pre-tested the positions of everything, but I will have to Bing, good evening, welcome in YouTube chat. Sorry, didn't see you. Kinda a little bit hard to follow all the chats when I'm streaming. So, and I really like this this DAC. I really like this one. Okay, this is not going to work. So yeah, the intermediate size is this one. I will need a third hand, freaking hell. It's always starts like that. And then the whole room's just a mess. Like this. Here we go. To hold it, just to hold it while I'm soldering it. Cut this thingy here. Again, I have them, so I use them. These thermal shrink tubes. By the way, if something goes wrong with my microphone, that's because it's time to change the battery, so tell me right away. No, that's not the right way. That's not on there properly. Hey, that's like freezing over there. Okay, let's just create a larger block. Heats up everything very fast and very good. Kinda like this. Not like everything's covered, but some of it is covered. Okay, give me a second. I gotta figure out my air plug situation. I need another pair. Just give me a second. Okay, I'm back. Almost. So that's the problem of this method of assembling, is that half of them I can solder outside of the case like this, and another half unfortunately inside. So this one, the shorter one, so the shorter one is gonna need a short one soldered to it. Right, or we can solder it here. I'm looking for the best way to like do soldering outside of the case. So okay. This will do. So let's do it like this then. So this will be soldered like this inside the case. So I guess let's solder this one, and this one, it's kind of sticking out. It'll be easier to solder it inside. Okay. So again, the short hand. A very actually convenient thing to do this type of work. There's quite some orthophosphoric acid left in form of this goo it started to turn into. So I'm thinking if it's a good idea keeping it there. I have a little bit of let's take another Q-tip. Can use some isopropyl alcohol. Try to get at least some of it off. I mean, I didn't expect it to be that gooey. That's my isopropyl alcohol. Well, yeah, immediately does a very nice job of removing this thing. Here we go. That's just I poured it into this small what's it called, small thingy. It used to be some crap, I keep forgetting basic words. Okay, let's just move on. So okay, now it's more or less safe from acid. Still a little bit. Oh, there's actually not a little bit, there's a lot of alcohol there now. So I guess using open flame to shrink the tubes, it's not really a great idea. First got to get rid of the alcohol. Okay, are we good? I hope we are. Okay, nothing started to burn, which is good already. So, and then this one goes here. And I'll show you how it's going to work in a second. Just let's prepare everything properly. Everything to be soldered inside the case. I don't actually even know how this digital audio converter is called, but you can see what I'm doing here. It's not really electronics even, it's just electrical pretty much work, so nothing special. So this would go like, not to this one, to this one. This will go here, maybe even in the hole, like this. So, and another one. I'm using an old way of soldering, very old way, using separate pine rosin flux. Because of it, everything gets a little bit dirty, but and you got to clean the tip of your soldering iron pretty often. But I mean, when you solder pretty thick wires, it's better to have more flux than less. And pine rosin, it's natural and smells good. This one is lead containing, but it doesn't smell. Okay, so you go here, you go here, like this. We need a little bit more of solder. Oh no, we didn't need more solder. It just worked that way perfectly the first time. Again, everything is in these shrinking tubes, but it's not needed. So how it's going to be? That's one side of things. So one goes here, this goes here, come on, fit in like that, and then this goes here. But before we solder anything to this one, we got to put on all the locking screws on it. So we might have a problem that I didn't think about. So there's the box of all the things that I needed for this build. I've prepared all the mounting hardware. Pretty much created myself sort of kind of IKEA set. Okay, so this goes here, and this we are going to keep on top, just not turning it around, just to make it way easier to solder. Does this? Yeah, this fits. This is long enough. Okay, so I don't know, these are some sort of spacers, washers, plastic ones. They were there, so I'm kinda using them. Oh, don't tell me. Okay, so the fuses inside these fuse holders going to be probably the smallest ones possible, because the whole thing not supposed to consume more than maybe half a watt even. It's not like a power amplifier, it's just a digital audio converter. So here we have it. Now let's add this here. The blue one is too thin. We got to use the black one. Like this, and even maybe through the hole. Yeah, why not? Plus these fuses, these cases for fuses, fuse holders, whatever they are, they cannot really by the look of it sustain any high currents. Okay, that's there. That's there. So let me just shrink it. So one's ready. This one's not attached, but technically it's supposed to be inside. It's supposed to be like this. It's supposed to be like this. You gotta just drill 2 round holes connecting for the socket itself, and that should be it, and 2 holes, 2 small holes for the screws. But I decided to do it this way because it doesn't really matter. This box actually is going to be hidden. That's why I'm adding these fuses to it. That's why I'm kinda not letting anything from the transformer, even the case of the transformer, to be exposed through the mounting hardware outside, because this thing gonna work completely unattended for hopefully for years behind my amplifier, pretty much stuffed away. So okay, we got one done. Now it's time to do another one, the same thing, but the socket's gonna be on this side like this. But the fuse for it's going to be here. Strange, I thought I covered everything. Here we go. Now it's covered in solder too. So what about this one? Yeah, has this sorta kinda slamified acid there still. Let's get rid of it. Q-tips. Okay. And while the alcohol evaporates from this one, I'm going to work on this one fork, solder once into it. So again, the same approach. This goes to this thingy, this lid of it. Come on, take the solder. Everything's dirty already because of rosin flux. I have a little bit of what's it called, steel wool here. And as you can see, the tip of my soldering iron is really bad. So just basic stuff, but it does work for me. Here you go. Hey, don't do that. We need a piece of the black tube. Here we go. So these are pretty big wires and pretty serious amount of solder in there, but it's the mains. It's like 230 here, 230 AC. Even though almost zero current, Just as I say, the milliamps it's going to be. Still, I'm treating it like the fuse should go first. The wires cannot go out before the fuse. So if something goes wrong. But I don't think anything goes wrong. The most dangerous part would be the transformer, and the transformer has been, well, I mean, there for years. Okay, now this here. So let's see, to make it kind of uniform. Which absolutely doesn't matter, but we're at least gonna have some uniformity at least inside of the device. So the blue one goes here like this, and the brown one goes here. That's all solder here. Not good. Oh, stop. Forgot about the shrinking tube. Well, a little bit dirty, but again, it's not flux that holds it together, it's the solder. Oops. I'm burning the case of it. Do we have it? Yeah. It's melted in a pool of solder over there. Good, 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 good. Here we go. This piece of wire, it's not prepared. Let's prepare it. So you add some flux, you take a lot of solder, and you heat it nicely till it starts burning your fingers through the sleeve. Okay, both ends are more or less ready. So maybe that's a little bit too long. But no, that's okay actually. It just goes deeper. Even if it's long, doesn't matter. It actually gets more contact. The tube. Okay, is everything okay with my microphone? Is it time to change the battery? Let me actually take a look. No, it's green here. It shows that it is green. So this type of stuff, like electrical connections and whatnot, there's no electronics here, it's just wires soldered to each other, nothing special. I've been actually doing since childhood. Well, not on something that would just have mains running through it, 220, 30, 40, but close. Well, close. 12, that was my maximum probably. Okay. 12 volts, I mean. Okay, these plastic washers. I don't know why we need them, but let's take them. If the manufacturer gave them to us, so let's use them. Here you go. And nut. Maybe not the right side, but don't turn. You got to stay this thingy up. I'm actually running this profile on my notifications. It should be a totally different profile. I forgot to change the notification profile. What was that, Kevin follow? I don't think it was anything. So restarting the notifications. Yeah, that's how it's supposed to be. So, and this, ooh, that's actually way too long. That's like way too long. Has to be like this. Okay, let's cut it to the length. We don't need like a lot of free wires. We will end up having actually some long wires hanging in there just because I made a stupid mistake regarding the board itself. I have a stripper that kinda electricians would use for this type of wires, but when it strips, unfortunately it takes off a little bit of the wire itself, a little bit of the core. So you just cut it a little bit with a knife and finish up with your teeth. And these wires are all slightly of different color. That's because they're just remnants. I didn't bother even to find a piece, one continuous piece long enough of these electrical wires for this build. These are actually no 0.5 millimeter square in its gauge. I don't know, like Imperial American gauge, but I think these ones are 0.5 millimeter gauge, and they are good. Oh, this side's not taking in solder. They're supposed to be good up to like maybe 1 kilowatt. Maybe no, 1 kilowatt. That would be 100. Wait a second. 5 amps. A little bit too long. So let's do it now. So let's fix this. Let's not forget about our shrink. It goes here. Because I cut it, it doesn't want to go through the hole, which is absolutely not necessary. But I have my OCD here. Doesn't want to go through. Okay, let me fix that. Just like that. This piece of wire feels like it is special. It doesn't really want to take solder. Go through the hole. Yeah, that's the problem when you cut them too short. Here we go. And here we go. Nice and drowned in a pool of melt solder. Okay, a little bit too long of a shrink, but that's what I got left here. Here we go. So we have all the things in here. These ones are not attached, but they are not going anywhere because of the cables holding them. It's time to push on the switch, the gigantic switch. It'll be extremely hard to take it out of here. So, but it goes in nicely and stays there. So, and pretty much for the switch, that's pretty much it. It doesn't need any special mounting. So now the wiring. So I guess this will be on the top and this will be on the bottom, right? So you go like, how to show it to you, like this. You go here, by the way, the button, the switch supposed to light up because, well, that's how it is designed. So it switches both the neutral and the neutral, neutral and the phase. Here we go. And this one is the same, but on this side. The central position is for the transformer. well, kinda gonna be a little bit too hard to maybe switch it connected, but I think we'll figure that out. Here we go. That's how it's supposed to be. This needs a couple screws, but I will, well, I mean, let's actually add them and let's check if the button lights up, because I'm kinda using it the other way around. So these two, going to be a little bit hard to install the nuts, but where's the screwdriver? Come on. Here we go, once more or less done, not going anywhere. Yeah, there's enough empty space inside for the transformer. The wires are not going to interfere, these ones. All this switching circuitry. Switching inputs. What for? I don't know, I just want it. Here we go. Not going anywhere. So one side is ready. Actually, I never checked the fuses. Oh, don't spin in there. Oh, freaking hell. It spins like crazy, which is not good. So what's this fuse? How many? Ah, no. 0.25 L. F 0.25 L. Is it 0.25 amps? Yeah, I guess I ordered them already from AliExpress with the really low rated fuses. These ones turning back and forth, that's kinda a problem. Yeah, and I don't have, of course, a wrench for these nuts. And the whole thing's turning. Okay, now I can twist them here, unscrew them without the whole thingy, the whole assembly of the fuse holder moving. Okay, the first test, that's actually that can be a little bit dangerous already. So there's no power yet, no power. Okay, and now there is power. So now we have mains inside and the light comes up. So it's C number 1, it's this one. Number 2 is this one, it's not powered. Okay, this part works. Though I don't need this light, the whole thing going to be tucked away. Okay. Well, if this works, then if this works, this one works, then this one should too. Let's screw it in. Again, prepared all the screws in the right quantities. All the nuts and bolts and whatnot. Hey, I need the small one. Where's the small one? Here we go. That's M3. So for me, actually drilling holes, making it all more or less even, making, well, especially like making rectangular holes and whatnot, that's a nightmare. That's the part that I absolutely hate. So that's why I did it off camera, and that's and another reason that it's actually it would be extremely hard to do here. Go. And it's good that this circuit is at least semi-disassemblable. At least you can remove the switch without soldering anything. The screwdriver is not really working here. I need another bit, but I'm too lazy to look for the bits. I'm just going to use another screwdriver. Here we go. Okay, so this part has been assembled. Where's the piece of cable? Already attached to the transformer. Okay, so, and this goes to the middle middle contacts over there of the switch, which is kinda, yeah, a little bit harder going to be. But okay, now what we need to do, we need to take some wires that we have pre-made already, and solder this thing to the transformer, its power supply. As you can see, there's already a little bit of a wacky job here. So I made not a mistake. I actually wanted to try it when I got it, but it had like the terminal here for three wires, and one of the segments wasn't just working. I couldn't unscrew it, so I just removed the terminal because I really wanted to try it. So and now I'm stuck with these just cables here. Cable wires. So let's take it outside of the case. It'll make things a little bit easier. So these need to go. That's like temporary stuff. Oops, fine rosin flux leaves a little bit of a residual here. Hey, I don't have holes. I'll have to use braided wick to clear holes up. Okay, this we don't need anymore. The wick. I need the holes back to mount, to solder the wires through the board. This is the old way people have always used before, had always used before those solder sucking devices were invented. So we'll have to go on the other side too. Almost there. Let's just turn it over. It should give us the holes back. I cut a piece of wick that already had solder on it and immediately lost it somewhere. Cut off just a piece. Here we go, we got a hole. One of the holes is back. Nice, almost clean hole. This one will probably need another go from the other side. Yeah, there is some solder left in the hole. It's pretty deep. Trying to use the corner of the wick to actually get the solder out. Okay, turn over. It's not like the wick is not gathering any solder, it does. Just there's always a little bit more left. This hole is harder to get back than the first one. Oh boy, okay. These two holes, yeah, the solder got pretty deep in them. Okay. Almost like there. Let me just try to pinch through. Okay, another atom then. Just use one of the cables. No, I can't shove it in while heating, but no through hole. And this is all cleanable, just a little bit of isopropyl alcohol. Yeah, actually, we're heating the board at this point. Okay, they're good all the way then. Just give me a second. Just a needle. And then where's the wick? Get the solder from the side of the hole with the wick. There is a hole, not that big though. Don't want to damage anything on the board, and here we got a hole here. These boards should be anyway pretty resistant to heating, because the way they're soldered, they're baked. Okay, I guess I will have to just pretty much go without holes. These ones are a little bit too deep. To the last one, and I'm actually kinda already a little bit tired of it. The last one is still obturated, so give me a sec. Let's just clean the board really fast. Yeah, not the best piece of rack for this. Mostly works, not the best cloth. More or less okay. This side. Cotton stays there a little bit, but the alcohol does the job. Mostly. Let's maybe try paper. I'd call it good enough. The battery is still green in my microphone. So then I will have to just solder them in this way, like from here. Okay. And again, because we are dealing with AC here, there's like plus 515, 0 and minus 15, but in fact it can be like 24, 15, sorry, 12, 0, minus 12, or it can be 24, 12, 0, so, and there's no plus and minus, there's no negative and positive. Okay, got this one through. We'll help it from the other side. The only thing is that the black one's in the middle. The middle one is in the middle. So that's supposed to be 0. Oops. This one doesn't look that good because of the sleeve going off. What's wrong with you? The sleeve kinda melted in a strange way. Let's try to do it more accurately. Ah no, it goes through. There's the hole. Turning it all around. So this is the power, plus minus 12 AC volts. Here we go. So the thing with this board is that, for example, you can move these connectors somewhere, unsolder them, or just solder something else to them. You can move the SPDIF connector somewhere else, but this is optical. The optical one you'll have to unsolder, then find a way to mount it somewhere else, in your case, and then solder it again. So optical cannot be just extended that easy, taken off the board and, well, moved to different position. And I need optical. I use optical. Every TV these days, they have optical outputs, and if they can actually make the sound, so if you're sending something to it, doesn't matter if you're watching like cable, antenna, or just a PC connected to your TV, if you can hear sound in TV itself, then TV is sending it to the optical at the same time. So TV is sending it to the optical, and from optical you can take it and send it to your receiver or amplifier. Okay, so let's prepare these ends. They are not prepared. Yeah, 2 steel cables and 1 copper. Well, not steel, some sort of alloy, but not copper for sure. Again, I'm just using whatever I could find in a box of cut wires, cables, wires. And this goes to the transformer. These ones, because they're made of this alloy, they need a little bit more heat to start taking solder. So we're almost done here. I forgot to twist this one. No, I did not. Okay. The copper one doesn't really want to take the solder either. If it doesn't want to take the solder, add more flux and give it some serious heat. From both sides. Here we go. So we got it pretty much going. We got it, well, not going yet, but soldered. So as for the transformer, one of the wires goes here, the black one goes here, and another red one goes here. That's already, as you can see, pre-connected, the way it would give us exactly 12 volt, and actually not just on 220 volts on primary coil winding, but specifically I adjusted it a little bit, played around with different types of connecting the coils to give us 12 volts on 235 AC input. So okay, and we will need again some little bit thermal tubes. So let's see, this is going to be like this. So the way we should do it, we should try to avoid any let's keep it like upside down. We should try to avoid any tangling. Well, I mean, a little bit is admissible, but only a little bit. So, and I kind of really learned to like these transformers because they are very easily available on Russian eBay / Craigslist sites. And Soviet industry produced all sorts of them for every possible with every possible type of secondary windings. So you just gotta take a look in the documentation for them and find the one that would work for you. Okay, this goes here, then this goes here. This is a little bit harder. We need a larger one here, and this cable wire, we shouldn't let it jump off when we solder to it. Like a small piece maybe. Oh, come on. That technically should do. Let's make it shorter a little bit. Okay, let's try to solder this, not destroying the whole. Yeah, it's not going to be really visible for you, because this wire that connects secondary windings the right way might come off. Yeah, and it indeed comes off. How do I keep it all together? Not the best idea, but maybe with tweezers. The tweezers gonna be actually cooling down everything here, which is a problem. The problem with this cable that it jumps off. It's springy. So then gonna use one to keep another one in place, something like that. Okay. I mean, I should actually check if the thing would still work after all this soldering. Because I'm kind of giving it some heat here. Okay, the microphone still good by the look of it. So, but everything works. This is the last solder joint here. Yeah, why I never can find the ones of the right size. There's like some bits and pieces here. Okay, that'll do. Oops, stop the tube. A little bit too long, maybe, to be properly covered with tube. Though it's 12 volts, so not that bad. But again, don't want anything shorted to anything here. Like all colors of shrink tubes we have here: black ones, yellow ones, blue ones, red ones, everything. Well, I mean, nothing standardized, I guess. And where's the lighter? Where did it go? Was here all evening. So let me just take these tubes away. It's so freaking late. I spent so much time preparing the stream. Where did the freaking lighter go? What the actual hell? Ah, here it is, standing like that. I couldn't see it because it was like like that. Okay, so this is supposed to be like this in here, right? Right. This is supposed to be like on top of it here. Now let's connect the transformer to the switch. And I made it harder for myself. So let's remove the top connections. Oh crap. Here we go. Stay in there. Stay in there, I say it. Like this. And you go back on this side. And you go back to this side. So now it's all wired up the way it's supposed to be wired up. So this board has some LEDs, and if we turn this on, some of them should light up, indicating power, and I guess if there is signal coming in. So it's auto switching. It detects whether the signal is going through the SPDIF or through the Toslink optical. So okay, moment of truth, magic smoke. So this is not powered down there. Power on. So here you go, just for you to be able to see everything. Okay, the cable is now under power, and haha, we have two LEDs on, so it is receiving power then. Monitors turned off. That's because I'm using the same technically power bar as for the monitors. Let's use another power bar. So here we go, lights up. Nothing is smoking. The transformer is not going to experience any load whatsoever. So let's try this side. And you cannot see it, but this light is on too. So let's try this side then. Yep, just the way I want it. It has two power inputs on both sides, but that's just for easy cable routing. Okay, so it seems to be receiving the power. Then let's attach the transformer. So just give me a second, just in case there's anything in the transformer. Shorting out the primary coil. yeah, with scissors, just because. So okay, this is going to be a little bit harder, but first we got to mount the transformer because it's the heaviest component. So unfortunately, this is why the case is so big, because of the transformer. I guess it's possible to just 3D print a case like this one, and this would be like here, so like almost half smaller than this case. But this is like a pre-made one, so. I'm going to try to just fix them one by one. Again, the transformer is mounted on this piece of plywood simply because I didn't want the screws, the bolts, whatever they are, that are touching the transformer's case, to be exposed on the outside. Since this thing doesn't have a metal case, and I tested this board, I couldn't get any interference on it. I tried with this transformer, tried with some other stuff, couldn't get any interference. Doesn't look like it needs a lot of shielding. We'll see, of course. It's always possible actually to do shielding. It would be just annoying. So and it's always possible, of course, to redesign the case. But if this works, and if it doesn't have any interference, and again, just by default, this board, just in the air, without any case, connected to this transformer, and I tried to use this transformer maybe to create like at least 50 Hz interference, it was just dead silent and clean. So, but this way of mounting insulates the transformer completely. Oh yeah, this is going to be not easy to just get in there. Oh yeah, this one's in the way. Here we go. Cut the threads. Now screwing it all. Pretty tight, because this is like the heaviest part of the whole assembly. Here we go. Look at this beauty. I'm proud of myself that I managed to actually make the screws, well, the bolts, whatever they are, screws here flush with the surface. So now this this is gonna be mounted. Did I? No, I did not make a mistake. It's just not going to be easy. Having actually disconnectable wires would have helped a lot. So like this. So first of all, this special screw here that keeps the line output. Here we go. And then unfortunately here I managed to drill two larger holes, two normal ones, and then when I try to make the small ones here larger, Robertson screws in Canada, the square screws. I'm sorry, Natsu man, good evening, welcome man. Not sure what it is. I'm not familiar with like translations for these parts. So, oops, stop. So I managed, instead of just making these holes flush, I managed to just drill them completely through them. So that's why these ones are not going to be flush, and then they're going to have even a washer like that. So the board is a little bit raised because of this screw, so let's make it less tight. Here we go. These ones we don't need extremely tight because the way I drilled the holes for the board, it ended up kinda a little bit bent when mounted, so it doesn't need to be 100% tightened, the screws here. So to just avoid bending the board, stressing it and whatnot, stressing it, putting strain on it. Oops, don't go anywhere. Here we go. The good thing that this board has all the mounting holes already, because some of them don't from AliExpress, but this one's kinda of the higher quality than the rest of the stuff, that I've seen. So for example, I don't actually remember current prices for DIY digital audio converter boards. Well, I mean, you don't have to solder the board, you just have to find the housing for it and give it some power somehow. So don't remember prices for these thingies, but when I bought it, and it was actually almost 2 years ago, so I'm not really fast with my projects. So when I bought it, this one was on the expensive side, but for DIY, of course. Because when it comes to just DACs, digital audio converters, there's a lot of things you can have there. So I'm just trying to get this not going. Here we go. And again, I'm just holding the nuts with my fingers when tightening it up, because I don't need to be need to go hard on this board. Don't need any strain on it. Don't need any bending, though I think it's well made and it's able to withstand some rough handling to some degree, of course. So okay, this is pretty much as assembled as it can be. So was my mistake, of course, that I removed the terminal here, the screw terminal for the wires, but one of the terminals, one of the segments of this terminal wasn't really working. So okay, let's try to test it, which is gonna be probably the hardest part. So untangle it. How did I? Like this. So not going to add any zip ties or anything, just a box like this. Lots of uses for this small box. But nothing's moving inside. That's a good sign. Okay, give me a second here. Got to get some free space on my desk. So testing will be a little bit harder. Than everything else. Just a second. So we will need a source of optical signal that I actually have. My second PC is currently doing this. Not this. Where is it? I don't know where is it. I cannot see my second PC here. Okay. I guess my second PC. Hey, where's the mouse? Is not being captured. Yeah, my second PC is not being captured because I haven't used this OBS scene collection for very long time. No, still no capture. I guess OBS needs a little bit of a kick. Okay, it's not capturing the second PC. I want to show you that the second PC is playing currently this music that's being sent via optical connection to my first PC. Now we're going to take this cable and just plug it in here, in this thingy. No, nothing's moving. Nothing's moving inside. So unfortunately the top of it is not flush. These two is kind of sticking out. So, but we will need some input here. Let me get some. I have enough of inputs on my desk here. Audio inputs, I mean. Because I don't know if you can see it, because I have this device. So this goes here. Oops. Yeah, that's sort of a small problem. Doesn't probably go all the way in because of the way the cable is designed, but that's okay. So, let's first check that we have any sound coming from coming in from this. So just give me a short second. A little bit of manipulating with signals in voice meter. So these are going to be mapped to, just give me a second, system settings. That's gonna be 3 and 4. 3 and 4. You cannot hear them, but if I make it a little bit more sensitive on the input. Yep, it's coming in. Good. So let's start another music on our second PC, something different from this. So YouTube is off. Let's see, maybe my music. Our music. Space Melody Lab music. Yeah, okay. At least this is not going to hit any content ID matches. Okay, so now we need to the hardest part. Get the optical audio connector. Oh boy, this is hard. Here we go. So the problem was the fact that the audio card, when it lost connection to the second PC, it lost synchronization over SPDIF. So, and right now this music is coming from my second PC. It's coming through this box. It's actually mono right now, my bad. Now it's stereo. So what you heard a little bit of distortion, it's because I'm capturing the output of this box with my audio card. So, but it does work. The signal's coming through this cable and is being output in digital optical, and is being output through this cable here. It works. Here we go. That's the box. Yeah, it's a little bit kinda crucified here, so I cannot move it up because this cable is too short, but it is working. We lost all sound for a second, but that's because of my this card, so audio interface. I guess all we have to do is just put the screws in and it's ready after 2 years of just looking at it and using the digital audio. Hey. Yeah, it's coming on the same line as the microphone, my bad. Yeah, it's a little bit supposed to be a little bit quieter now. So I guess this is it. The scene works. Okay, let's switch to this here. Turn this off. Start this. So disconnected optical, and here it pretty much is. Kinda dirty, but it's a case. It's good housing. It's pretty thick plastic. It won't go anywhere. It's all mounted with a lot of screws inside. The board itself with like 3 M3. The transformer screwed in with 4 M4 to the plywood, and plywood to the transformer, another 4 M4. So this is tightened. This is kinda staying there. So these 2 screws with nuts and bolts. Well, so, and by the way, the board, this small board, actually additionally being held here by this screw. So even though I tried to measure my best the distances between all these connectors here to drill the holes, I ended up kinda drilling one hole not centered, but at least I drilled a right-sized hole for the optical connector. Those things, they can become pretty chunky. So it's a little bit out of focus. No, it's not out of focus. Okay. So I'm glad that it came together absolutely as I wanted it to, without any problems. So I guess it's time to call it a day. Thank you very much for watching, people. Oops, I pressed the button that controls additionally the Winamp. Okay, so thank you very much, people, for watching. A strange stream, but I do DIY from time to time. I wanted actually to do a little bit more soldering, but I guess we're a little bit out of time for that. So a little bit out of time. So I will do a little bit of secondary soldering, some secondary things on my own, not on stream. What else? Nothing. So YouTube crowd. Well, I mean, if you like this video, subscribe to the channel, like it, the video, I mean, leave a like, that helps. But I understand that's not something you'd expect to see on a gaming channel, but that's my channel. I do that stuff, not often, but I do. I try to tinker with electrical things and electronics on basic level. I do basic soldering. I sometimes build PCs and whatnot, so things like that. But mostly it's of course gaming. So, and Twitch crowd, don't leave me yet. Thank you for staying with me tonight. Let's find somebody to raid. If you give me a second, just give me a short second. We don't really have lots of viewers, but we've had some visitors tonight, and this is not my normal time. 100% understand the fact that's not my normal time. So let's take a look at what's going on in science and technology. There's a ton of automated streams in science and technology, which is not fun. Not fun at all. Let's see if I can find something live. Something really live. Oh boy. There's somebody building something. Somebody's doing some soldering by the look of it. Currently looking for something. Hard to tell. Okay, let's see if we can raid them. They seem to be live, so just a second. Read art by robot. Well, I mean, the links in the Twitch chat. Thank you very much for watching, people. See you all tomorrow. Goodbye and good night.